Welcome to lesson 5.3. In this lesson, we're going to be graphing square root and cube root functions. In the first, we're really just going to we're just going to see what these graphs kind of look like. And then not really worry about transformations and stuff like that until another example. So first one is just square root of 3x. Just make a chart to start, right? So we have x values of 0, 3, 12, and 27. And notice how we don't have any x values that are negative because you cannot take the square root of a negative. So these are the, so if x is 3, 3 times 3 is 9, square root of 9 is 3, that's why the y value is 3, and so on. If x is 12, 3 times 12 is 36, square root of 36 is 6. These are what they look like. It is a curve that starts from the origin. What are the domain and range of that function? Well, the domain would be all x values greater than 0, and the range would be all y values greater than 0. So I know this looks like it's leveling off, but it's never going to get to horizontal, if that makes sense. It will always be increasing. So I guess to the second question here, is the function increasing or decreasing? This is an increasing function. It will never level off. The y value will continue to increase as the x value increases. The amount of that or the degree to which it is increasing will decrease, if that makes sense, but it will never level off. All right, let's look at a cube root function here. We have cube root of 2x, so same deal. Make an xy chart. So these x values, we do have negatives because you can take the cube root of a negative number. More generally speaking, even roots, you can't do negatives. Odd roots, you can do negatives. So in this case, square roots, no negatives. Cube roots, yes, negatives. As you can see, it does go both directions. In terms of the domain, it goes forever left and forever right, so there is no restriction on the domain. Same thing with the range. It will go up forever to the right, and it will go down forever to the left. So there is no restriction on the range. All real numbers for both domain and range. The function is considered increasing as you go left to right. So I know if you think about it from the origin, it's going down that direction, but when the question is asked, is the function increasing or decreasing, we're talking about it from left to right. This is increasing the entire time you're going from left to right. All right, we have two you try it questions, so pause here, give this one a try, and then come back and check, and then we'll do the same for the second you try it question. All right, I picked these 3 points. The reason why I started with an x value of 5 is because the expression under the radical is x minus 5, and it can't be negative. So 5 would be the smallest value of x that I could try. So 5 minus 5 is 0, square root of 0 is 0. 6 minus 5 is 1, square root of 1 is 1. The reason why I jumped to 9 is because I wanted the expression underneath the radical to evaluate to a square number. So 9 minus 5 is 4. If you chose 7 or 8, you're going to get square root of 2 or 3, which is fine. It's just those are harder to graph. So 9 minus 5 is 4. Square root of 4 is 2. So I plotted those 3 points. It starts here, curves out. The domain is all x values greater than or equal to 5. The range is all y values greater than or equal to 0. And this is an increasing function. All right, let's look at the next one. Let's clear all that out. So same deal, try this one. We'll pause it, try it, and then come back and check. So here I chose x values of -9, -2, -1, 0, and 7. because those are numbers that will create a cubic number under the cube root. So -9 plus 1 is -8, cube root of -8 is -2, and so on. You plot those points and you get that curve, right? Domain and range are both all real numbers for this, and it will be increasing. All right, let's take a look at the next example.